Okay, question 9. So I hope we agree that it's not been too rough so far. Just to kind of recap, and we're about halfway through, aren't we? So we went through some basics on vectors, nice and straightforward. Fractions, again, easy. Equation of a circle, the area, or a sector within a circle. Simultaneous equations, equation of a straight line, which I said, don't forget they're kind of the same thing, really. It's just two variables equal something. We did the nature of roots, so we got a discriminant, and there's a tiny bit of problem solving here with the shape, but ultimately that turned into a Pythagoras question. Okay, so a 3D Pythagoras, and then we solved the equation, which was actually really just it's almost like a combination of fractions and equation of a straight line. Okay, just manipulating formulae. Okay, so this has been similar to some of the questions at the beginning of the other papers. The function f(x) is defined by this. Express f to the 5 as a fraction with a rational denominator. So it's kind of fusing two questions together a little bit. So first of all, it's saying express f to the 5 as a fraction with a rational denominator. So express f to the 5 is the first bit. Okay, so in f, I'll go back to code actually. So f to the 5 is just 2 square root of 5. All it's saying is instead of x, write in 5. Okay? The only other way you can write that is maybe to say, when f of x equals 10 or something like that. And what that means is 2 over root x would equal 10. Okay, so this is when the equation equals something. But when it's f bracket 5, that's saying, well, instead of x, we've got 5. Okay, so that's the two ways they can ask that question. Okay, so that's the first bit. And the second bit is saying a rational denominator. So we know denominator means the bottom of a fraction. We've done loads of that so far. What does rational mean? Well, right now we've got a surd. Okay, so that just goes on forever and ever and ever. Irrational would not go on forever. Okay, so basically it means get rid of the surd. So the easiest way to do that is to times it by root 5 over root 5. So what we're effectively doing there is times it by 1, because root 5 divided by root 5 is 1. So we're not actually changing the nature of the value. We're just kind of just changing the way it looks. If you think on it that way, okay? So we're expressing it differently, but we're still got the same number. Right? So that's going to give us 2 root 5 divided by 5. And then we can take that any further. Okay, we're just looking at primes there. Okay. Again, if you get surds, don't forget something like root 10 can be broken up into root 5 times root 2. Root 12 can be broken up into root 4, root 3, which would be the same as 2 root 3. Okay, 2 root 3 plus 2 root 3 is the same as 4 root 3. Okay, because they've got the same surds. I just add the factor in front. This is not really the question. This is me just riffing. Root 16 over 4 is the same as root 16 divided by root 4. That's one that people forget as well. Okay. Surd rules that I'm forgetting. No, that's better. So yeah, that's some surd chat. But yeah, that's what the question's saying. It's saying substituting for 5 and then just get rid of this irrational number, this infinite number on the bottom. I'd like a nice number on the bottom. Okay. So that is now a proper fraction. Okay. Good. So 2 marks. Let's see where they go. Yeah, so 2 over root 5 is your first mark, and your second mark is no to do that. Okay. Good stuff. Okay, question 10, sketching graphs. So, oops. Here's our axes. The x and upper y. So sketch the graph of this. On your sketch, show the coordinates of the turning point. So turning point and the intersection with the y-axis. Okay, now, first thing, let's look for the basics, okay? This would be y is equal to x squared, okay? Now let's rewrite that as y is equal to x plus 0 squared, okay? Plus 0. Now, the second number here controls how far we move it up and down. Okay, up. And the number inside the bracket is looking at how much we move it left or right. Okay. Now, obviously, for the orange, the up and down, positive would go up the way, negative would go down the way. Counterintuitively, for this, a negative in the bracket is actually going to move it to the right. Okay, I'll do that. Okay, now it's easy to forget that. Obviously, you got that wrong. It's just one mark. But yeah, let's think a bit more about, is there a way we could remember that? Okay, so say our equation we were looking at was just y is equal to x minus 3 squared. Okay, bearing in mind that this standard y is equal to x squared is just the same as y is equal to x plus 0 squared plus 0. Okay, so we've got a minus 3 in here now. Now we know that when y is 0, that's the turning point, isn't it? Yeah? So we were to put that equal to 0, z0 equals x minus 3 squared. The turning point is going to be when x minus 3 is equal to 0. Yeah? So then x has to be equal to 3. Okay? So that would tell us that our graph, if it was y is equal to x minus 3 squared, so just the first bit of this, would be over here. I'm trying to do this is going to get quite busy quite quickly. I'll just dot it just now. But I'll just draw it and then I'll undo it. That's terrible. So it'll be over here. Okay, so we've moved it over 3. So there's our 3. Okay. So that's a little bit of how you can remember, like, which way do I go. But you should know that you just change the sign and move it, okay? I've moved it up 1. So that whole graph is then going to be up like this, okay? And that turning point value is going to be 3, 1. Okay, because we've taken our x squared and we moved it over 3 and up 1. That's all that's saying. Move it over 3 to the right and up 1. Simple. Okay, so I'm sorry this is getting quite busy. What I'll do is I'll keep that, okay? But I'll just quickly redraw a kind of simplified one down here, okay? Okay, so what's the turning point? So 3, 1. Nice. It also wants this intercept as well. How on earth would we find the intercept? Oh, I don't know. Very difficult. Well, we know that y is equal to x minus 3 squared plus 1. And we know that when it crosses the y-axis, x is 0. Okay, so if it crosses there when x is 0, I'll keep the same pen actually, sorry, so many pen colours, then it's 0 minus 3 squared plus 1. So minus 3 squared is 9, plus 1 is 10. So that point, and I would just write 0, 10, just to be completely accurate, okay? You probably could write 10 and get away with it. I'll just write that, okay? Marks for this question. I'll just check the time, we're running out. Loads of time. Marks for this question. Let's see, you get coordinates, you would get your 10, and also understanding, I've actually not even discussed this, that the curve we've got is in this shape, it's in the U shape. Okay, so because it's a positive x squared, it's in that shape. A negative x squared graph, just to draw my original, would be like this, and then it's the exact same rules with this. Okay, moving it left and right, up and down. Okay, so that's your 3 marks: understanding the turning point, the intercept, and the shape. Okay, so I hope I'm sorry that diagram's a bit messy, but that's the principle behind what we're doing. Okay, we're manipulating the y is equal to x squared graph. I think that's the best way of thinking about it. So if you forget which way it goes, or up or down or whatever, just try and remember that process. Okay, think about the turning point. Okay, turning point is the minimum value, and for an x squared, that's going to be 0. Okay, so that should help you almost just solve and say, yeah, okay, I don't need to just remember rules, I can think it through. Alright. Oh, you know what? I'm starting to love these little questions as well. Okay. Simplify tan squared x, cos squared x. Right, now, there's only 2 rules. Oops. First rule is not to just randomly draw on your paper. Your marker will think you're insane. There's only 2 rules you need to remember. Okay. sine divided by cos x is equal to tan x. Okay. And sine squared x plus cos squared x is equal to 1. These are the only two things you need to learn when you see these. Okay? You're going to be using these to simplify. Okay? So tan squared x and cos squared x. Now what does that actually mean? Well, it means tan x squared times cos x squared. Okay, that's the convention that's been adopted for tan, cos, and sine. If you think about it, it's actually quite strange. You don't do that for other functions. But yeah, that's what it means. Tan squared x is tan x times itself. So yeah, that is tan x. Tan x times cos x. Cos x. So we can't simplify cos. To be fair, we could rewrite cos. We could say actually, that's interesting. We could say cos squared x is equal to 1 minus sine squared x. We could actually use that. That might come in handy. But for now, let's just work on tan. So tan is sine over cos, okay? So that is sine x over cos x times sine x over cos x. I'm running out of time. Times cos x, cos x. If we put all that together, that's just going to become one very big equation, isn't it? Where we're going to cancel out cos's from top and bottom. And that's just going to leave us sine squared x, isn't it? Okay, so if we're timing them together, that would have then just given us effectively this is one big fraction. And then we cancel top and bottom. Okay? Yeah, nice and straightforward. It's probably a way to do it with that as well, as an idea, maybe changing that into sine, and then. But I think just now, and this is, I don't have time to go through that. But yeah, don't forget these are the two manipulations you're using, and then that's it. Okay, dead straightforward. If you see tan, get out of tan. Pardon me, if you see sine squared or cos squared x, think about rearranging it that way. Okay, yeah, they're actually quite fun. So you're going to get a mark for, what's the mark scheme say? Yeah, you're going to mark for knowing that sine x over cos x is equal to tan x. And then they just mark your final answer, not a lot in that. Okay, good stuff.